Hi guys, today for my final project presentation, I will be discussing the course project and relating it to what I've learned over the course of this class. The bike sharing system is going to include multiple steps throughout the course of each customer experience. The system will have to facilitate the ease of these steps to ensure a smooth process from start to finish. Now, the first step includes the actual renting of the bike at a particular docking station. In order to streamline the accessibility and convenience of this product, the bike should be trackable, and this will ensure the availability of bikes at each docking station. The second process in the bike rental system is the registration, payment, and billing that must occur in order to ride the bike. This is a straightforward process as it involves a simple point of sale system. This purchasing method needs to be a quick and easy process that can be completed on an easy to use application available at each station on a mobile phone or on the computer. Since this requires the storage of sensitive customer information, there will be added information security measures in place to protect client data. The last process includes basic upkeep to ensure the bikes being offered are in working condition. This can be handled while the bikes are being transported to the necessary stations during off hours. There can be a basic checkup technique in place to make sure they are being properly maintained, and each bike should be set up with a QR code for easy identification as well. Because of the nature and structure of this bike rental system, it will use a decentralized cloud-based architecture with a local backup in each clustered POS system. Now, this will make it quick and easy to access, transfer, track, and store information throughout the entire company. And due to the fact that the information needs to be transmitted to publicly accessed docking stations as opposed to secure locations, this business requires a certain degree of flexibility and storage efficiency, which is exactly what the selected architecture offers. Each docking station is installed with a networking module that connects them to the internet. A virtual private network, or VPN, will be utilized so that the information can be transmitted more securely to and from the cloud. And with a cloud-based system, the docking stations would not only be able to communicate directly with each other, but also with the consumer registrations transacted through the online option. So any order, whether initiated via docking station or mobile application, will be communicated and processed instantly to the appropriate location. And for added security, there will be a firewall in place to protect any information being transmitted. This will instill confidence in the consumers as well as ensure no confidential information is being stolen. This information will also not be lost thanks to the multiple backups in place. And there will be a backup held on the cloud that is constantly running and updating throughout the entire day. This will keep all the information up to date and accurate in case of any data loss. And in addition to the cloud backup, there will be applications running on each local docking system that back up data to each other. And with this added function, the stations can still be utilized by the consumer even if the systems are offline. The components at each station will include hardware such as the electronic bike docks and a computer to complete the transaction. This computer will need most of the basic components required to operate a personal computer, like a motherboard, a RAM, and hard disk. The input devices on each station will include a keypad used for the purchase of passes and a credit card reader for payment. A screen will also need to be included in the system as an output device to provide the customers with a visualization of their order. Each computer will need to have an operating system as well as application software that will allow the consumer to purchase and unlock a bike from the computer. Now, moving on to the risks, there are many possible risks associated with a bike rental system. First and most obvious risk is the physical theft of the bike. This is, however, fairly well eradicated by the payment structure and bike tracking system. Another potential risk is the lack of data protection. With a system that requires the use of internet, there's always going to be a certain amount of risk that goes along with it. The protection of data transmitted over the internet is essential, as this information could include personal information, credit and debit card information, and even company internal records. Such security is imperative to ensure the safety of employees and consumers from identity or financial theft. And having multiple authentication methods and access controls is in place. These are tools that can be used to strengthen the security. Encrypting the data and transmitting it through a virtual private network, as I spoke to before, will provide a good amount of security as well, along with the implementation of a firewall or intrusion prevention system. Now, in order to implement a system to support this bike rental business, it would need to start with the research to find out where to build each docking station. And once this is complete and the stations are built, you can work on implementing into the computer's software that includes the simple and easy to use POS system I mentioned. This will need to be able to track the number of bikes available at any point in time, complete the payment transaction, and unlock the bikes rented. The software implemented will need to include a payment structure, the storage of user information, subscription and registration details, bike rental history, and much more. This historical data can then be used to find trends and improve the customer experience in the future. There will need to be multiple employees maintaining the bikes as well as returning them to the required docking locations at the end of each day. And that is all I have for you today. Thank you.